We are live. That I say it every time. That little intro video gets quicker and quicker every time. I think Anna's playing a little trick on us and making it like 2 seconds now. But welcome to another episode of Make Azure AI Real, and we have a special guest this time again, Sandra from Cohere. So I told you I was gonna like decide on one, so I'm just gonna go with both. But welcome to Make Azure AI Real.
Hi, Corey. Thanks for having me. Delighted to be here today and chat about all things RAG agents.
Nice, and that's what we will be doing today. I want to know. I'm, always interested in the audience in terms of we have a global audience. Sandra, I think you're based in another part of the world. I'm based in Stockholm right now. But let us know where you're joining from, and also since we're going to talk about both Agentic RAG and Cohere, I want to know just have you ever worked with any Cohere models before? So drop us in the chat. Where you're joining from, and your experience with Cohere. If this is your first time joining us, though, Make Azure AI Real. This is like I think it's like our fifth, sixth episode. I'm losing count, but this is a series where we don't just. This is my Sandra. This is my like marketing made up thing. But it's what we don't just talk AI. We do AI. We've been building each episode this little general theme around building a AI startup education or some sort of product around it. Last episode, we did something with Mistral models where we summarized a whole bunch of articles and looked at the different models that are out there and how they compare, which was really fun. And this episode, we're going to look at Agentic RAG. Like I said, in the marketing is out. It's like, I remember RAG being all the rage. Everyone was talking about it. We need RAG for everything. And now it's like agents. And now we're going to combine both of them. If you're joining us, if this again is your first time, we do have another episode coming out. We're going to be, I think, focusing on fine-tuning on what that looks like. But today we're going to focus on what Sandra's bringing to us with his Cohere models. So Sandra, go ahead and take us away. Explain what is Agentic RAG and why should we be excited, really?
Okay, why should we care?
Yeah.
Let's go. Can you see my slides?
Soon. Now we can see it. Single shot RAG is not enough. I love the intro.
Exactly. So first up, I want to set the context of why we're talking about Agentic RAG in the first place. Like, what's wrong with just simple vanilla RAG that we cannot get the best performance out of? And let me show a couple of examples that illustrate it. First of all, as users start to play with RAG systems, their needs become more and more sophisticated and complex. So you can really see it in user queries and in the type of information that the user is trying to access via a RAG system. Here we have a query asking about customer churn rates change in the last 3 months. When a system gets a query like this, it needs to decide, where the heck am I going to pull this information from? It could be residing somewhere on our Slack message where our sales team is talking about it. It could be residing in Notion Wiki. It could be somewhere else, depending on what your system is. So this type of query will require from our RAG system / RAG agent to work with multiple sources and decide on the fly which source is going to be applicable. Plain RAG cannot do that. Agentic RAG will do that, and we're going to show today how. Next scenario, very common one, is you get a really beefed up user query that requires multiple steps in the reasoning to be able to answer it. So in this case, we have a question about top 3 tech companies in terms of revenue growth. And then the second part is, how many employees do each of these have? So first, we need to find out that the system needs to find out what are these top tech companies, and then it's going to find out how many employees they have. It requires this sequential process. Similarly, you also have queries that require reasoning in parallel. So when you have a query that asks about 3 different companies and number of employees for these 3 different companies, to get a successful, nice answer, accurate answer, you want to run in parallel number of employees for NVIDIA, number of employees for Microsoft, and for Google. And more and more, because we are applying RAG to different data sources, you want to be able to use structured data. So that means tables. That means plugging it into various APIs and gaining information out of it. In order to be able to use this in the RAG setup, you will have to use Agentic RAG. Now, I like to think about Agentic RAG as an expansion. So we are slowly shifting from the paradigm where single-shot RAG system requires the LLM to go grab this information from an external source, come back and give an answer. Agentic RAG is building on top of it and kind of expanding what the model can do with that information, how it performs that action. Each company has its own take on what agents are, really. So I want to set some ground foundations for how Cohere thinks about Agentic RAG. We are working with our models to be very friendly towards using tools. And this is really what we mean by agents. For us, agents are LLMs that use tools. And in case of tools, each of the data sources will be represented as a tool. So it could be a static tool, but it could be a dynamic tool. We're going to talk about it in a second. So tool can be any function or a service that can receive the information, send objects to the model, and then tool takes in the query as an input and returns a set of documents. On the higher level, I want you to have this image of what happens in an Agentic RAG workflow. So in the first step, the user provides a query, a question via an app or a notebook. In our case, we're going to look at the notebook today, and then passes it to the LLM. LLM then needs to make a decision. Is it going to use any tools? And if yes, what kind of tools? It's going to generate some sort of plan for that, and it's going to generate tool calls, if any, if it needs tools to be able to use to be able to answer the query. Then the app or the notebook is going to execute tools and then send the results back to the LLM. And then LLM is going to generate a response with citations that is hopefully satisfactory to the user's liking. However, oftentimes,
I was just going to say, well, one, you got some great feedback from the audience. Mohammed from LinkedIn has said, just amazing. So that's just a general one. But yeah, very clear. But I wanted, because what we just saw, we did the poll, and 25% of the audience has used Cohere. So that means majority haven't. But maybe this is something new in terms of both the models and what we talk about tools. Could you give us some examples? I know you're obviously going to go to the code example, but what do you mean by tools, and like what would be something in an agentic RAG flow would make sense as a tool?
Okay, so let's actually look at this example. So this is our Cohere interface where you can play with the models, just typing your queries. And I asked the model, who is the host of the Making Azure AI Real show. So I did provide different tools to the model. You can see Python interpreter here, calculator, and web search. And then the model decides which of these tools is going to be used to answer this query. So in this case, the model is deciding that it's going to search host of the DevRel show, so it's going to use the web search. But then, based on the first search, it's going to come back and say, okay, I found the series and I know what it is about, but I couldn't find the host of the show. So I'm going to now change the query a little bit, and I'm going to try it again. So this is exactly what happens here. The query is a bit edited, and we are focusing on the host of the show. And finally, we are getting the response, which is obviously query, and then we get references. So you can, by tools, we mean a very broad array of things. You can use web search, you can use calculator, Python interpreter, you can use various functions, you can use various APIs, and you can use APIs that plug into Notion. You can use APIs that plug into web search. I am going to show you an example of tools, but think about it as broadly as possible, honestly.
I don't know why, but it feels so good to be recognized by an LLM. Like it knows who I am. Thank God. Like, wow, yes, I am the host. That is true.
Yeah. So today we're going to, there are various agentic workflows and a lot of exciting scenarios that we can talk about here. I'm going to zoom in on this specific example where we have a query And the model needs to decide which data source that it has on its hands is going to be the most relevant to answer that query. So we're going to look at the notebook by my colleague Mir Amir. This is just an example notebook in a series of 6 notebooks that show, honestly, all these different scenarios here and how to work with LLMs to be able to successfully, to be able to successfully create an agentic workflow. So, Curry, it's now your time to make some music.
Well, yeah, the music time. Well, we do have a question that's, I think, general enough at least. But it's, we're talking about data, we're talking about RAG, especially about tools. Like you showed this example where it's about looking at the data source of a, let's say, a company or database or whatever, and then also combining that with maybe you're retrieving this from the internet. So one of the questions that we get in, a question that we have gotten in this audience now is just around keeping some data confidential, right? In terms of, you don't want that the client's data, when there's sensitive data, going into training the large language model itself. I don't know. We have our take at Microsoft, but maybe you have your own, canned answer on this, and from a Cohere perspective, because obviously you deal a lot with RAG and data. So I'd love to hear your thoughts on it for sure.
Yeah, so for the most secure deployments, we have 2 options, actually. We have private deployments that are hosted, that are facilitated by our partners. So Microsoft is a great example. If you want the private deployment of a agentic RAG system using Cohere models, you can get a license for private deployment via Microsoft. And I'm not sure exactly what's the implementation there, but my understanding is, and Kari, tell me if you want to jump in and fill in the blanks. My understanding is that the information that you're retrieving does not go back to the provider, so it does not exit your system whatsoever. Everything stays where it is, and there are guardrails in place, and you don't have to worry about the information going to the model.
Right. Yeah. So everything, especially when you're using Azure, that stays in your Azure environment. So it doesn't go into whatever model that you're using, whether that's an OpenAI model, Cohere model, Mistral model, doesn't go into training that later on for anything else. So that's probably the advantage in terms of using an environment like Azure, because again, confidentiality and sensitive data, whatever your use case is quite important. So that is a great one. We also have a this is hello Bernard. Bernard's one of my favorite people in the community, because he's always asking very specific questions. I don't know if you want to take it now before we switch to the code, but if so, or if you want to wait until the end, let me know. Are you ready?
I'm ready. Yeah, let's do it.
Okay. That's nothing too bad. So he's saying the R+ model capabilities are multilingual RAG, multi-sub, so text-oriented as far as he understands. You can correct if not. Does it also support graphics, PDFs, or then to choose another model from Cohere like Aya or Re-Rank?
Yes. So great question. We are working.
He's always got the great questions. Hello, Bernard, by the way.
Hello, Bernard. So you can expect more and more all of the models from Cohere to have these multi-modal capabilities. At the moment, Command can work with text in the sense of you can have a RAG system in which you're using the embed, which is the multimodal model. You embed both text and image, and then you will be able to retrieve both text and image and provide an answer to the user. So R+ itself is not multimodal. R+ only uses text modality, but it can work in tandem with embed multimodal, which is using both text and image. And you can create a multimodal RAG pipeline using embed in tandem.
Nice. Okay. And like I said, only 25% of the audience has worked with Cohere models. So we have been, I think, assuming everyone knows and the R+ model, but we do have a question from the audience about providing an overview of the R+ model. So maybe you can give the quick elevator pitch of what exactly the R+ model does, advantages, use cases.
Yes. So excellent question. R+ is our flagship family of generative models. So these are the models that generate text. These are the models that are really fun to play with. R+ in particular, they are models that are designed to be in this kind of middle section category from 30 billion parameters to 70 billion parameters, if I'm not mistaken. And so what they do is they are optimized to work with RAG use cases, and they're optimized to use with tool use. So when you use them in the context of agentic RAG, this is where you can get the most out of them. They are we are primarily working with enterprise clients, and so these models are optimized to work with business types of use cases. The boring bread and butter of summarizing the reports or generating the reports, creating briefs, analyzing data, both structured, which is tables, PDFs, graphs, whatnot, but also unstructured. Yeah, I think you can apply them to any type of use case that you can think of for generative models, like all of the models out there that you have from other providers. But in particular, if you're looking for something that's enterprise friendly and works primarily with the business use cases, then I would say Command R+ is your model to go to.
Nice. And then I think, yeah, the point of like optimization, right, in terms of RAG and agentic RAG is probably, I mean, again, one of the questions to get, especially on this show, is like, which model should I choose? And lots of people don't know that there's models that are, optimized or, I wouldn't say specialized, but yeah, they perform really well for certain use cases. And knowing that, I think, is very good knowledge for people to have when they're, see a whole big model catalog and they're like, what to do with all of these?
Yeah.
I just try them all. So Paula, I hope that helped ground this is a RAG joke, ground the conversation on what we're talking about when we're talking about Cohere models. But let us know if you have any
questions. So that is on the RAG R+ front, but frankly, we have built both Command R+, embed, and re-rank models. These are like 3 different types of R models to create this nice RAG pipeline. So if you use them in tandem, then you're going to get the best RAG results. All of them are optimized to work together for RAG type of use cases.
Nice. Okay. So let's get to the code. Let's do it.
Yes, let's do it. So I am running this notebook locally via VS Code. And for that, I have created this folder, Agentic RAG, where the notebook is. And also, I'm going to be using this file tool dev, which I'm going to talk about in a second. So first of all, to make it work in this particular scenario, you will need to install Cohere, LangChain, LangChain community, and experimental libraries. I'm going to tell you why. You're also going to be needing Cohere API key and Tavily API key. I know it's not a good practice to share API key with the world, so I'm going to destroy these keys, but I added them here for simplicity. So you're going to have to go and fetch your Cohere API key and Tavily API key. It's super straightforward to do this. And then you also need to make sure that this tool dev file is in the same directory as the notebook. So what is this tool dev thing? So first of all, this is where we store all the definitions and functions for our tools. It is an external file because, as I mentioned, this notebook is only going through this one particular use case of routing model queries to exact data sources. There are multiple other fun use cases to explore like this, and there are more notebooks that we've created for this series, and all of these notebooks are going to use tools that are in this file. So we just package them here to make the code nice and neat. So that's why it's a separate file. But looking at the tools in particular, so today we're going to use search developer docs. This is basically a function that simulates a search in the Cohere developer docs and is going to return a list of mock doc examples. So in this case, it's going to be hard-coded and it's going to be like a dictionary list. But normally, you would probably create some sort of retrieval system. I'm just going to demonstrate how the model is going to choose different tools depending on the query. So I didn't need to create the entire retrieval system. This is just like a few snippets of the docs that will help to identify the search developer docs as a tool. Next up, we have search internet. This is going to perform a broader internet search, and we are going to use Tavily as our web search. You can use any web search provider. Our API is super flexible when it comes to choosing a web search. So it could be Brave, it could be honestly whatever works for you. We have chosen the Tavily from LangChain because it takes 1, 2, 3, 4, 5, 6 lines of code approximately. So we like it for its simplicity. So what it does is it retrieves up to 5 results with advanced search depth, and it's going to include both answers and it's going to include raw content. We also need the API key, as I mentioned, for this particular one.
Do you know what that search depth parameter means exactly?
Honestly, no.
Yeah, I was hoping you did, so that we can. Maybe anyone in the audience, can someone go look at the docs quickly and let us know if you don't already know by hand?
Look at Tavily docs and tell us what it means exactly. Anywho, coming back to the surface level explanation. So next we have search code examples, and it's going to work very similarly to this search developer docs. So we have hard-coded examples, which are really titles from code examples from Cohere, and they will be returned if the query that the user provides is going to require tapping into code examples. So on the high level, these are the functions. We also have tool metadata that is stored here. And here, basically, these are dictionaries that define each tool as a structured JSON-like schema. And we have details here, such as function name. So in this case, it's search developer docs. Function description. So searches the Cohere developer docs. Use this tool for queries related to Cohere API, SDK, or other developer resources. And we also have parameters, including required parameters, just a query. So tool definitions make it easy to select and invoke specific tools. And each schema will allow the system to understand what each function does and the inputs that it requires, and makes it possible to perform this structured text across whether it's developer docs, internet, or code examples.
In terms of like troubleshooting agentic RAG pipeline, do you think, like as a developer, if the right tools aren't being called, should I go to the tool definitions first as troubleshooting, or if there's something else that might improve the outcomes of what the LLM is choosing in terms of tools?
I think tool definitions is the first thing to go, especially making sure that this description is very, very clear. If you make sure that the description is clear, you should not have any issues with model choosing the wrong tool for a given scenario. So honing on those descriptions would be my first big step to debug.
Makes sense.
Okay. Coming back to our code, so we import OS, Cohere, and JSON. From tool dev, we import these tool functions and tool definitions. We also initialize Cohere client here with an API key. Please don't abuse it.
They're already on it. They're already on it somewhere. Somewhere is already like it.
Yeah, very bad practice. Please don't copy me and don't quote me on this. This is a bad example of using the API key. Anywho, we have a functions map here. So what it does is basically it's a dictionary that is going to map tool names as strings to the actual Python function that can implement them. And you can easily expand on these tools and add more tools to your functions map. We have only 3 tools here because it's a very bare bones examples that is just going to demonstrate this capability. But you can have as many tools as you want and cover as many diverse use cases as you need. So here we have tools, which is basically just listing the tools for the API. And the agent is going to use these to look up the answers depending on the query that it's going to get. And now over to the core agent logic. So first, I'm going to talk to you about the system message. System message is super important, and it's very important to get it right. System message is this kind of meta prompt where you set the context for for the instructions to the agent, and you're going to emphasize what it needs to know and how it needs to operate. And in our case, we are specifying here that you're an assistant who helps developers use Cohere, and you're equipped with a number of tools that can provide different types of information. If you can't provide the information you need from one tool, you should try other tools if there is a possibility that they could provide the information you need. So this really nicely says the context and kind of modus operandi for our model, and is a very useful system message to have. Now,
one question is, would you define like you kind of kept it general here in terms of you have some tools, choose ones, but have you seen other people or even implemented yourself actually defining the tools within the system message as well? So you have a Cohere documentation tool, you have a web search tool, so that the LLM kind of knows that, or is that effective at all?
You can play with that. I haven't found it to be particularly effective. I remember when we were building a Discord bot, for example, for our server. We tried the preamble with specific tools and without them, and it performed very much in the same fashion. I think it's better to keep it more general, honestly. But if you want, you can also tweak the system message so that it accommodates these specific tool examples. But then it keeps it kind of locked, right? And then you will need to update it whenever you are updating and expanding the list of tools that you want the system to use.
Good. I mean, I've put it in the system message before, and I don't know if I'm wasting my time. So, because like here's your point, you have to update every time you add a new tool. So that's good to know that maybe the results are the same. So maybe I'll stop.
It can do really well without it. So you really don't have to bother, and you can just like speak on the higher level to it.
And Bernard has come back, and he not an update on the Tavily docs, which I was looking for, but he has recommended a VS Code extension called Cloak that hides the API keys. So
yeah, thank you,
Bernard. There you go. I haven't used it either, so maybe I can try it. Thank you.
I'm gonna try it next time. Thank you, Bernard. I'm very ashamed of my practices here. Okay. So now we're moving to the model, and the model is going to be Command R+ August edition. This is the latest edition of our R+. R+ is the biggest model, and as I mentioned, it's optimized for RAG and tool use scenarios, so it's a perfect candidate for this particular code. Now, on the highest level, I want to tell you that we're going to work in 4 steps. I don't know if you remember this graph I showed, but it's going to basically reflect that. So in step number 1, we're going to get the user query. And the model is going to decide kind of in step 2. No, between step 1 and step 2, honestly. The model is going to decide if it has enough information to be able to generate a tool plan or not. It's going to generate tool calls, if any. So the model like gets the user query. If the query is like, hi, then the model is like, okay, I don't need any tools to be able to answer this. I am not going to answer this using any fancy tools. I'm just going to return a response here, which is going to say, hi, how are you? But if the query is like, who is the president of the United States? Then the model is like, I probably don't have this information handy and up to date. So I am going to plug into something like web search that will help me find the exact accurate information for this particular time and place, and then bring it and ground my response with that information coming from that particular tool. So step 1, getting the user message. Step 2, generating tool calls with functions that it needs to call. Step 3 is going to be essentially running tools and executing them, given the input. So the tool will pass the results to the model. And then step 4, using the results, the model generates a response with citations. This might end up being a loop, which I'm going to talk about in a second. But let's go step by step. So we have this core function run agent. it has two arguments. One is the query, so user query that represents the user question. And then we have this optional argument called messages. Now, messages helps us maintain the conversation history. And if messages is set to none, we're going to initiate an empty list because we want to store that conversation history throughout. Why do we care about that? When the system is able to check and append all the messages to the list, it's going to keep a detailed history of the conversation. It allows our model to understand the context of the current query. And otherwise, if, for example, we're asking who is the president of the United States, we get the response, and then we're asking how old are they? Without the conversation history context, our agent is going to get lost and is not going to connect the they or he or she to the president of the United States. So we want this conversation history in order to keep our agent informed and on top of the next query and next interaction with the user. And messages is something that our API is going to expect and keep on building with the flow, where first we have a system message, which we just talked about. Then we're going to have a user query, which we're going to log in a second. Then we're going to have tools, and then we're going to have an assistant. So back to the code. Now, if there is no current system message, we are going to add the system message that we've specified here. This is important because we want this context, we want this clear instruction to the model, but also we want to check if this instruction is already there. If it's there, we don't need any clutter, so we're gonna skip it. We append, and this is the first time. This is the first message we append to the entire system, to the entire messages list. We append it with the role system and with the content system message. Now, moving to step one. So the agent is going to review all messages lists and is going to decide if it can directly answer a user query or if it's going to need the tools. For now, we print the question, the query. This is kind of like a demarcation list. You're going to see we do it just to make it nice and kind of visible to separate different parts of the output. And then we append to the messages the role user and the content query. So we have two messages in our flow already. We have the system message, and we have the query from the user. We have the perfect context. Nothing is lost. We're really happy about it. The system can be on top of what it does. Moving to step two. Here we have CoChat function. This function interacts with Cohere API. So the model is set to command R+. We're going to call command R+. Command R+ is going to review all the existing messages, so the system message and the user query. It's going to also look at the tools available that it has on its hands, and we're going to set it so that the randomness of the output is very low. This is a Agentic RAG system, so we want the output to be very precise, and we don't want the model to hallucinate, obviously. That's why it's so low. Now, when this function is called, as I mentioned, command is going to read the messages, understand the context, review available tools, and then it's going to generate the output based on the input. And possibly, if that output includes, if that output will require any tool calls, it's going to generate a plan for a plan and tool calls to call specific tools. So results of this call are going to be stored in the response. The response is structured in such a way that we have the tool plan if we are making any tool calls, obviously. If not, we don't have any tool plan or tool calls. We have tool calls. We also have, somewhere here, content, and we're going to have citations, if any. So,
and is this tool plan that's built into the The Cohere API, where that gets to, okay, that's really cool.
Yes, that's built in. That's specified by our API. So so at this stage, in this step 2, the model is already deciding whether it's going to use any tools or not. And if it's not going to use any tools, it's going to this entire while loop. There won't be anything in the tool calls. So this entire while loop is going to be false. So we're not going to execute anything. We're not going to plug into anything. It works great in scenarios like I mentioned. So it's like, hi, or how are you? And then, we're just going straight to the messages like, I'm great, how are you? So, however, in the case of Agentic RAG, where you have a more complex query that requires tools, the model is going to generate these tool calls. And now we are going to print the tool plan. This is basically just for human purposes. Like, we want to know what the tool plan is. We want to know what the tool calls are. So we are going to print it for us, and I'm going to run a few examples at the end, and so you're going to see how it works. We are also going to iterate through each tool call. So TC is a tool call, and we are iterating over each tool call in these tool calls. And we're going to print the tool name, and we're going to print the parameters, because, again, we want to know exactly what happened there, what kind of tool was used, and what was the reason behind it.
That's really great, I think. I mean, one of the questions we get from like an agentic workflow is, one, visibility first. I think that's like should be a stock standard, right, to know what the LLM is choosing. But then the other one, which I'm not sure if you have this ability, but like to stop the LLM or to direct the LLM in some type of way. So, like don't make that. Maybe it's a really expensive API call. I don't know, but like don't make that API call. That's like not the right way to go. I don't know if you have anything in terms of that, in terms of like monitoring or directing the LLM in certain ways, or like making like the LLM engaging the user before it engages the tool.
You can structure your code so that the LLM, before it executes any actions, is going to ask for user permission or for user input. I am working with agents like this at Cohere. So, for example, we have our IT support channel, and there is an agent there. So whenever there is somebody that's asking about IT support, the agent is going to run this query, formulate a plan, what it thinks it's going to do, what are the next best steps in order to troubleshoot this query, and then it's going to ask our IT admins whether it should proceed or whether it should formulate something else. So you can absolutely create a system that requires the human in the loop, and I think this is the safest at the moment, the safest, the most reliable option to include it.
Does the agent have a name? I bet it does.
It does, but I don't remember.
What? Sorry. Oh my! So, you need to apologize to the agent. That's it.
I know. Yeah, I'm so sorry. So anyway, so here we're going to, at the end, we're going to append again everything to the messages list, and this is going to involve the role assistant and tool calls, what the tool calls are, and the tool plan. Now, we do that because, as I mentioned, we can run this in subsequent iterations of the loop, and each time the model is going to look at the updated messages list. And so, for example, if at the first iteration it formulated a plan, tool calls, it executed the tool results, and the results are not satisfactory, then it's going to, again, get back to formulating another plan, another tool calls, and then it's going to execute those tools and then do it in a loop until we get enough information to provide the response. So the model is going to refine the response based on these inputs. That's why we're appending everything and logging everything to the chat history. And it's a really fun situation when you see this loop happening between step 1 and 2. So basically, as I mentioned, in the first iteration, the model is going to look at the messages, decide if whether it needs tools to answer the query. If tools are needed, it's going to provide a plan, provide tool calls, and these tools are then specified and executed, and then the results of these tools are processed, appended to the messages with the role tool. After appending the results, updated messages list is passed back to the model for the next iteration. Model reevaluates what it did. So we have a system message, user query, assistant tool plan, results from the tools. Based on this context, model is deciding again, should it generate a complete response? Does it have enough information in order to do so? Or should it call additional tools to fetch more data and be more accurate or more informed?
Well, I mean, one of the questions we have from the audience, from Bernard as well, is, we talk about these tools again fetching data, but what's the limitations of it? I guess essentially inserting data or performing other types of actions. So, instead of you saying hello and doing a web search, you saying your name and then it's inserting that into a database or other systems out there. What is there any limitations to what tools can do, really?
I would say we're just like, it's kind of a GPT-3 moment for tools right now. We are trying to figure out what they can do rather than where their limitations are. I have not come across yet limitations in terms of the use cases for the tools at the moment. Yeah.
I mean, essentially, these are just functions. So anything you can do in a function, right?
Yeah.
Should be able to do as a tool.
Yeah. I invite you, Bernard, to try and break it.
Oh, he will. He will. I have faith and confidence. You'll find new ways.
Okay. So essentially, like this loop that's going on, I think it's very cool for a few reasons. One of them is because our agent is not going to assume that it has enough information upfront, but it's going to decide dynamically in each iteration whether it needs more and needs to call tools that can provide more complete response, or if the tools are not necessary at all and it can skip and just go to generating the answer. Now going to step 3. This is where the fun begins, I think. So we are now looping over each tool call in these tool calls in the model response. And this is the function that is essentially our retrieval, the retrieval of the information that is happening. So we are executing the tool call here. We have the model come up with the tool call is executed, and it's going to be stored in this tool result. Functions map here, what it does is essentially accesses the tool function that corresponds to the tool name provided by the model. You can find it here. And this bit parses the argument field of the tool call, which is provided as a string, into a Python dictionary. So our model specifies the tool parameters in JSON format, but it's going to convert it into a string, into a Python dictionary, so that it can be used as argument in a function call. And now we need it because this functions map is where Python functions are that expect specific arguments. And yeah, the model is going to provide the query argument in the JSON format. The line converts the JSON into a format that the function can accept, and then call the function. So this variable stores the entire result of the tool function call. For example, the result of our search, like who's the president of the United States. And this is where the actual retrieval of external information happens. And this is going to be helpful for us in the tool content. in the tool content, what happens is we're initializing an empty list. And we need it here because imagine that we're going to ask about this president of the United States, and we're going to get back 5 results from Tabeli. And so at the moment, in the tool result, all of these five results are just morphed into one thing, which is not going to be very helpful in case we want to provide citations and explain exactly where the information came from that we are citing, what kind of sources have been exactly used to answer the user query. So in tool content, we are kind of breaking down all these tool results into 5 executive results as single items. And so we initialize this empty list, and then for data, which is a single item in tool results, we're going to format each result. So in this line, what happens is we have the JSON dumps, which makes sure that each data item is going to be serialized into a JSON compatible string. Optionally, we can add an ID field that is in the document object. Otherwise, our model is going to auto-generate the ID, the unique ID for each tool call and each tool result is going to be useful for, as I mentioned, mapping which information came from which exact source, and it's going to be displayed in the response. So now that we have all this, we're going to append it. And what happens here in this line is basically new entry is added to our messages list. Role is tool. Then tool call ID references the specific tool call. Then the content is the formatted results from the tool. And now, as I mentioned in our messages, we have this flow system message, user query, and now the tool. So this updated messages list, now including the tool results, is going to be sent back to the model. And the model uses this additional information as context to refine the response. And then it's, as I mentioned, going to decide whether it has enough information or whether new tool calls are necessary. If they are necessary, we're going back to step 2. And we're going to generate a new tool plan, tool calls, and go through the motion once again until we have enough information for our response. When the model is going to provide the full response, you're going to have these tool calls empty. And when that's going to happen, we're going to exit the entire loop. So that loop only is going to work until the model is looking for this information from tools. Once it has enough, then we're exiting the loop. And then the final response from the model is going to be appended to the messages again, role assistant, and content is going to be a response, message content. And here, this 0 bit is accessing the first element of a list, essentially. And the text is going to extract the actual text content from the first response. So now what's left really is to print the final response and print the citations. We have most of the job done. So for printing the response, we're just printing this, and we're printing the first this first element from the list. For the citations, we have time? Yes, we have time. So for the citations...
yeah, we got about 10 minutes. I guess you have the time too, so this is good.
Yes, perfect. So we have this variable called variables source. And this is a custom variable we introduce here to toggle the verbosity of the source output. It can get very detailed and quite noisy for our human eyes. And so if it's true, then we get all this detailed in-depth context about the sources. But if it's false, then we can control the output and have a concise version of it, displaying only the essential information we want it to. So In here, we are checking if the citation field exists. So if the model has been using tools, most likely, yes, the citations will exist. And so if it contains any data, then we're going to print the citations. If there is no citations, we're just skipping the entire thing. But if it contains citations, then we're going to print it. And then for each citation, we do something that helps us clarify and easily search through the information sources. So each citation in the citations provided, we're going to do something like this, which helps us to start and end are basically indices where they represent the exact characters and help us identify the exact position in the response text where we cite a portion of information. So it's helpful, for example, useful for like formatting user interfaces, and you want to display which part of the given answer is based off of a citation. You can, for example, highlight the cited portion of the text. And in here, you will know exactly like where this text begins, where this text ends. And this is the exact text that is being cited. So we're also printing sources. We want to print a list of sources, and IDX is essentially like a variable that represents index of the current item. It's a zero-based integer, and for us humans, we're approaching citations like number 1, number 2, number 3. So that's why we're adding this +1 just for making it human-friendly, really. We are also looping through the source, and then if the verbose source is true, then the line is going to print the full content of the source. It's optional. If it's false, then we keep the output concise. So again, full source content can be very detailed, very noisy. So it's only going to be shown when it's needed. And then we return messages. And here, so it returns the entire messages list. Now it includes the system message, user queries, tool calls and their results, model's final response, and any related citations that were used to generate this response. If we run an agent, now we went through everything. If we run our example agent, and we are going to give it the query, how many languages does embed support? Messages here is not provided, as you can see, so it's going to default to none. Let's run it and let's see.
The moment of truth, everyone. Brace for impact.
Let's pray it works.
The API key still works, so you haven't been throttled by anyone stealing that?
Hopefully. You guys are so nice. Okay, so we're running it. First, we have a question. How many languages does embed support? So this is our user query. The model decides to call search developer docs. We see that this tool has been chosen. And the tool is going to retrieve the results. And you will see that, so this is the response. And then we will see in the citations exactly which text has been part of the final, which text is referenced to other data sources and exactly where it starts, where it ends. Yeah, you can also see here the parameters. So in this case, it's the reason for choosing this search developer docs is because we have this argument, how many languages does embed support? So this is example number 1. And example number 2, we're going to ask it who are the authors of the sentence BERT paper, which is hopefully going to trigger the web search. So you see the plan is I will search for the authors. The tool call is indeed search internet. And the response is Niels Reimers and Irina Gurevich. Yes. And the model is citing the sources. There are multiple sources for that. And finally, we have a query, any tutorials that are relevant for enterprises. And here we just want to trigger the code example tool.
It's thinking. That one took a little time. So you really see that it's actually the whole process.
That did take a little time, but as you say, we use the tools search code examples, and it's returning several tutorials relevant for enterprise, probably listing all of them that were there in those search code examples that were hard coded in the dictionary. So yeah, that is pretty much it from me.
Cool. We did have some questions. One question was around providing a link to the notebook available. So we already put that in the chat, but Anna, maybe you can throw it on the screen. I just linked the Agentic RAG docs page. I think you can see that. I think that's probably the best one to give both what you've said and the code examples I think are there. Yes. Bernard has said he's going to name his his agent McFly or Dr. Brown. Back to the Future, because I am apparently a time machine person that can control time. Today or tomorrow, I can do that. Was a general question from Rashmi about data in different vector databases or different indexes in the same database because of the nature of the data. So you're separating this because of it makes sense to have it that way for the data. Yes, will this help? But I think maybe a lot of times people ask this, will it hurt? So, but is there any advantage to that, or maybe some guidance you have? I know we were talking about agentic RAG, and this is more a RAG-ish question. So, take it away.
Yeah, it's. I hate this answer, but it's true. I think like it depends on the use case, and it depends on the data that you want the model to use. But I think having one vector database is probably like, especially when you're just like trying to play with like an example use case, is going to be better. And having everything in the same database is going to be easier for you to begin with, and then you can build on top of it and build more complex pipeline. But yeah, it's very much a RAG question. It's not exactly an agentic RAG question. And yeah, the answer is it depends on the use case, and I know it sucks. So sorry about that.
No, sometimes it's not the answer you want, but the answer that is right. And then Ashok, more of a comment, not a question, but was talking about vector when we were talking about vector databases and storing semantic meaning of the text. We can also use that for additional context in the prompt. So, we were taking the prompt itself or the user, and then making that determine the tool. But I guess also adding anything from the database itself to add more context for the large language model, I think is what his point is.
Mm-hmm. Absolutely. Generally, the rule of thumb is the more context you can provide to the model, the better. Like it's hard to create like too much information for the model in order for it to break. Rather, you want the information to be concise, but the more information you can provide about what's going on, the better.
Yeah. And I think we'll end it with the LinkedIn comment. We're getting these like one-word comments from LinkedIn, which I love. Debriesco has said fantastic. So we're going to end it there because I think that just sums up everything that went down. I always say this, Sandra, thank you for joining us on Make Azure AI Real, and also to the audience. You spent an hour with us. You could have been anywhere on the internet right now, but you spent a whole hour with us. So for that, I'm truly appreciative. And also, Sandra, I'm truly appreciative of you sharing this amazing knowledge and resources around Agentic RAG. And I can't wait to see what everyone builds with this knowledge. Come next time, we'll hopefully have a whole bunch of experts on and building this stuff. We can go into other topics as well. So we'll see you in the next one. And Sandra, thank you for joining us and sharing this amazing stuff.
Yeah, thanks for having me. And yeah, guys, start building. It's going to be fun.
Perfect. Bye, everyone.
Thank you, everyone, for joining us. Thank you so much for another great session from our speakers, Corey and Sandra. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 23815, and we will see you at the next one.